Hello everyone, welcome to this session on what is DevOps. Today in this session, I'll not only be telling you guys what is DevOps, but I'll also be telling you guys how you can make DevOps as a career option. So let's get started. So the first thing that I'm going to show you guys is what is DevOps exactly, and then move on to discuss how you can make DevOps as your career. That is, why should you become a DevOps engineer? Once that is done, I'll tell you guys what is a DevOps engineer exactly, and then move on to discuss a roadmap where I'll tell you guys what all are the things that you have to learn in order to become a DevOps engineer. And then we'll conclude this session. So also guys, if you have not subscribed to the Intellipaat channel already, please subscribe to it and also comment down any queries that you have with regards to this session, and we'll be happy to answer it for you. So now let's go ahead and get started with the first topic, which is what is DevOps. Well, if you have followed the software development evolution, you will know that there are three methodologies of software development which are very important. The first one being the waterfall model, then we have the agile model, and then we have the lean model. So waterfall model was basically devised because we needed a process through which we can develop software, right? And that was what waterfall model gave us. After that, we realized that developing software is taking a lot of time. It took us years, if not months, to develop softwares, right? And this made the customer satisfaction to go really low. And hence we needed a new method through which we can deliver software faster. And hence we invented the agile method, right? So agile method solved that problem, and we further iterated it and made it even better by using the lean method, right? So these three methods are basically used to improve the speed with which we developed softwares, and that basically solved the problem of customer satisfaction, right? Now this was solved, but the question which arises over here is, then why did we need DevOps? So now let's go ahead and understand what is DevOps exactly. Well, DevOps aimed at solving a very different problem. The problem between the customer and the company was solved. DevOps basically focuses on the problem which is within the company. Now, what is the problem within the company? So basically the software is developed by a team which is called the tech team or the technical team. And the technical team itself has two sub-teams which are called the developer team and the operations team. Now, there were problems between these two teams. Now, what was the problem? Let's go ahead and understand. Well, the work of the developer team was to basically develop software using code, right? So they used to code that application, and then that application was then forwarded to the ops team or the operations team, which basically used to upload that particular application onto the server. Sounds simple, right? But it isn't that simple. Now, let me tell you some of the problems that were faced. For example, I'm a developer, or you are a developer, and you developed an application. Let's say your system configuration, it's i5 CPU, and then you have 8 GB of RAM, you have Windows 10 installed, and then you have PHP 5.6, and then you have probably Java 7 installed on your system, right? So this is your system config. Now you developed software and it is running fine on your system. Now the problem arises when you give the same software for some other person to run. Let's say you give it to the ops person to run, right? Now the ops person tries the best to have the same environment. So let's say he has an AMD processor, he has a Windows 10 operating system, he has PHP 7, yours was 5.6, his is 7, right? He has Java 8 installed. So these are the environmental differences which are there between the ops team and your system. Also, it could be that, let's say you are developing a software which requires a higher software which is not there on the production system or on the testing system. Again, there will be an environment mismatch. So what used to happen was, when you were able to you were done with your software, you used to forward it to the ops team. The ops team in turn used to send your code back saying it's not running on their system. But it's actually not your fault it's not running on their system, right? They have to check the environment, they have to set everything right, and only then it will work, right? But imagine if there are 50 developers and all of them are developing their own piece of software, or all of them are doing their own piece of work. All of them could have their own environments that they're working in, right? And similarly, ops people will have to manage all those 50 environments for all those 50 developers. This was basically a very hectic task. And the frustration was that the ops team used to send it back saying, you know, the code is wrong, it's not running on our system, please check the code. But the developer team, it was not their fault also, right? They did their work was finished, and this was the problem. There was a lot of back and forth between the developer team and the operations team. This was the first problem, that is the environment mismatch. There were a few more problems. Let's discuss those problems as well. Now let's talk about the second problem. The second problem was, let's say you as a developer, you forwarded your code to the testers, right? Now it will take some time for the testers to basically go through your code, find the bugs and send you the report back. Now you can either wait for that time or you can start off with your next task. But the problem is when the bugs come back, you have to again leave your work, then start off with the first patch of code and again solve the bugs, again send it to the testing team, wait for the feedback to come back again. So it was again a process which was not well structured. A lot of back and forth was there. So this was again a problem which had to be solved. The third problem was that there was no continuous feedback which we were receiving. Let's say, there are functional tests, there is a test that you do through manual testing and you find the bugs and everything, right? But what happens when the user uses it? Right? When the user uses your software, there will be some other kind of bugs which comes up. So how do you capture that feedback and incorporate in the developer's work? So there was no continuous process for that. So these were the problems that had to be solved, and these problems were solved using DevOps. Now if you focus on the word, it is a mixture of two words, dev and ops, right? Which basically means we had to bridge the gap between the developer team and the operations team, and the answer to that was DevOps. Now let's see how DevOps basically solves this. So guys, DevOps is not any tool, it's not any set of tools, it's basically an idea. It's a way of thinking as to how software should be developed, right? So it follows a life cycle which is basically continuous. If you look at the life cycle of DevOps, it basically resembles the infinity sign, right? It starts off from plan, then it moves on to code, then we build the software, then we test the software, then we release the software, we deploy the software, we monitor the software, and then we again come down to planning the software again. Right? This is the life cycle which is followed in DevOps. Now, how does this solve the problem of what we were facing before? The environment mismatch, the time taken to give the testing feedback, and also the continuous feedback which is not coming back to us from the customers. So let's solve the problem number one, which is the environment mismatch. So there's a tool in the DevOps lifecycle which is basically called Docker. So Docker is basically a very lightweight container system which basically can duplicate environments for you across multiple systems, right? So that can also be done using a virtual machine. If you guys know what a virtual machine is, it's basically yet another operating system which is installed in your host operating system. But the problem with the virtual machine is that it takes a lot of space, right? With Docker containers, the container can be as small as 50 MB. So if you are developing software, you develop it inside a Docker container and then you just give that container to your ops team, and once they run it, it will run it as it is, as whatever is specified in that container is. Let's say the container has around 1 GB of RAM, it's following some AMD 64 architecture, it has certain set of softwares installed in it. They will exactly be the same even on the ops Sky system. So the environment problem was solved. Then the software problem was solved using automated testing, right? So instead of asking the testers to test your software, what you used to do was you used to connect the life cycle of the code to your testing lifecycle, where the developer will automatically push the code to GitHub, which is basically a place where you upload code. It will automatically detect that the code has been uploaded. It will push the code onto the testing server where your testing suites are basically placed in, and your software will be tested, and whatever logs are generated, let's say there is a bug which has been identified, that will be immediately made back to the developer, right? So like I said, DevOps is basically an idea. It's basically a way of developing software, and you use all these set of tools together in the way of a DevOps lifecycle to basically achieve what we call the DevOps lifecycle, right? So we had Docker, we had Selenium, which is basically an automated testing tool. The third problem that we had was basically the continuous feedback that we needed to receive from our customers, right? So whatever customer got whatever bug, that had to be immediately reported to the developer so that he can add it in his plan as to what are the things that he has to fix next in the software. So this was achieved using softwares like Nagios, which continuously monitor softwares, generate logs, and whenever there's a log which of a bug type or a critical type, it is basically mailed to the developer. This is a problem that has been faced by a particular customer, and this is what needs to be solved, right? And this is continuously generated and added in the developer's plan. Now, how is the DevOps lifecycle achieved over here, guys? So when you plan, let's say, what is plan? Plan is basically when your architect comes in and tells the developer, this is what we have to do, right? He distributes the work among the developers, which is then in turn coded, right? Which is then developed by the developers, which is basically the code stage in DevOps. Then you have the build stage in DevOps, which basically resembles the compiling stage, where the code is compiled and is basically output in the form of an executable. When you achieve that, it is then tested on the testing server, right? When the tester code is tested, it is then moved on and it is released onto your GitHub branch, which basically is then deployed onto a staging server where you check the final things of the software, whether everything is working fine or not, nothing is breaking, right? And when that is achieved, it is finally deployed onto the production server, right? When it is deployed on the production server, then the monitoring stage comes in, where the software which has been deployed on the production server is continuously monitored, and whatever bugs are coming in, it is again going back to the plan stage. So this is how the infinity sign in DevOps basically works, and this is how basically the whole DevOps lifecycle works. Alright guys, the main thing to focus over here is that no part in the DevOps lifecycle is manual. Everything is automatic, right? And that solves the problem of the back and forth which is between the developer team and the operations team. That is, once a developer commits the code onto GitHub, it will automatically be tested. If there is any bug, it will be immediately mailed back to the developer and he can immediately fix it, again try to commit onto GitHub, again it will be tested, and if everything goes well, it will automatically be deployed onto production, right? Obviously, there are a lot of stages in between, there are a lot of tools which are used in between, but yes, this session is about what DevOps is, and I'm sure this session would have helped you clear your doubts about what DevOps is and how is it different from the various other models that you studied while you were basically discussing what software development was. Alright guys, so now that you understand what is DevOps, let me tell you guys why you should make DevOps as a career option. So let's go ahead and start off with why should you become a DevOps engineer.
Now let's look at some facts, guys, right? So according to Glassdoor, the average salary of a DevOps engineer is $100,000 in the US. Now this doesn't mean that you don't get salary above $100,000, but the average salary of a DevOps engineer is $100,000 in the US. According to payscale.com, a release manager, who is basically nothing but a DevOps manager, you can say, earns around 9,50,000 per annum on an average in India, right? According to Indeed, as of September 2019, that is our current month, there are 7,000 plus vacant DevOps engineering jobs that you can apply to. Okay, so this is the current scenario. This is the current scene in which you can get jobs for DevOps engineer. Moving forward, now let's talk about the average salary of DevOps engineer, what we have summarized from the previous facts. So in the US, the average salary is $100,000 in annum. That's what we just learned. In India, the average salary is 5,69,000. If we take into account freshers who are becoming DevOps engineers, even experienced people like a release manager or a DevOps architect or a cloud DevOps architect, all of them, the average salary which you get is 5,69,000 an annum. And obviously, I have friends who are DevOps engineers who are very senior. They must be around, when I say very senior, not in terms of the number of years of experience, but in terms of what all things they know. And they easily earn up to around 20 lakhs per annum and even more than that, right? So if you talk about people who are 10 to 15 years experienced in the IT industry, they can easily get even up to 45 to 50 lakhs per annum. That is the upper limit that I'm telling you in India as a DevOps engineer, right? And in the UK, it's 62,500 pounds an annum. That's the average salary of DevOps engineer. Moving forward, now let's talk about what is this DevOps engineer role. So we understood, okay, so there are a lot of jobs out there and people are earning a lot. But what is this DevOps engineer role? What does it take to be a DevOps engineer. So let's first understand what is a DevOps engineer role. So basically, a DevOps engineer is a person who manages your application's life cycle in your company. For example, let's say you have a set of developers who develop an application. Now, the journey of the code of that application from the developer's system to the production system, to the point you are able to access that application from your phone or your laptop or from an app, is what DevOps is all about, right? So there are a lot of things which happens in between, from reaching the production system to and from the point where it's just been coded on the developer system. Right, so what happens is, when the developer develops the code, it has to be first tested, right? So there are some automatic suites that we have that can basically test your code, and once you test code testing is done, right? So this testing could be more of like, is your code readable? Is it understandable enough? So if this kind of testing is there, this happens on the lower end when you push the code by the developer. After that, there are some functional tests which have to be done. But before that, what happens is, before the production environment, there's a staging environment and there's a testing environment where you basically deploy the application first to see how the application is basically functioning. And the tests which have to be done on this, they are basically automated, right? So basically the application is deployed over there with all the dependencies involved automatically, right? And then the application is tested automatically, then it is staged, and again further it is tested for any edge cases, and finally, if everything goes well, it is deployed onto the production. Now this life cycle is planned by a DevOps engineer, right? And this life cycle is basically automated by a DevOps engineer. So a DevOps engineer's job is to plan out, like, if I have 100 people in my tech company, right, how to get work done by 100 people on the same product, right? How to distribute them work, how to plan out their activities. So all these things are basically planned by a DevOps engineer, and a DevOps engineer basically plays a key role in architecting how an application basically would be deployed when it's on a certain platform, right? Moving forward, guys, now let's talk about the skills or the tasks basically which a DevOps engineer does. Right, so a DevOps engineer is basically expected to be an excellent system administrator. He's expected to know about how to deploy applications. He should know about virtualization. He should have hands-on experience in network and storage. He should have an experience in coding, right? What that basically means is, you should not be a hardcore developer and you should not be able to create mean stack or merge stack applications. What that basically means is, if you read some lines of code, you should be able to understand what is happening in the code, what is the logic behind that code, right? So that much proficiency is expected from a DevOps engineer. Apart from that, soft skills are also a must, because the DevOps engineer role is also sometimes a customer facing role, wherein they are basically expected to ask the requirements of the customer, and according to that, they're expected to lay down a plan as to how things will be done. Right, so they should be acquainted with most of the automation tools which will basically create the whole DevOps lifecycle. Like I told you guys, that DevOps lifecycle requires automation. Automation is at the heart of the DevOps lifecycles, right? So you have to be acquainted with a lot of automation tools if you are working with the DevOps lifecycle. After that, you also need to have software testing knowledge. Now, the automatic tests that I was talking about, they are basically created by software testers, right? And the implementation is basically done by the DevOps engineer, but you should also understand how a software testing suite is basically created, right? You should basically know how to create a test from scratch, so that if you are deploying a test and if a problem occurs, you should know exactly where the problem is occurring. Right, and finally, he should also be acquainted with all the security best practices which goes into creating an architecture, because obviously you are dealing with a product. And if it's a product based company, and if you're dealing with a product, you are basically handling the heart and soul of the company, which earns the company bread and butter, right? So the most important aspect of this is security, So there should be no DOS attacks on your application. Your application should not be like the code that you're deploying, it gets leaked out somewhere. That should not be the case. So you should be ready for all the edge cases, and you should devise a foolproof security architecture for your application too. And these are the kind of expectations that are basically that people have from a DevOps engineer. Now moving forward, guys, I talked about a lot of big things. I talked about you knowing security architectures. I talked about you knowing a lot of architectures. I talked about you knowing automation tools. I talked about you knowing in and out of being a system administrator. Now, how do you get all these skills? Like if you're a person who is from an IT background or from a non-IT background, and you feel, DevOps is a thing that I might be interested in switching on to, how do you become a DevOps engineer? Okay, so let's try to answer this question by first listing down all the skills that we have to learn first. Okay, so we have basically taken up some jobs from different job portals, and these are the skills that are expected from a DevOps engineer. So this is a job from the Unilever company, and these are the requirements that they expect from a DevOps engineer. So the DevOps engineer should be good in Python. He should be good with Ansible, Chef, or Puppet. So that is either of these tools he should know. He should know Jenkins, he should know Java, he should know Docker, he should know Kubernetes, and he should also know about operating system, virtual machines, containers, proxy engine, etc. Right? Don't get scared with these terms, guys. I'll give you a solution. I'm here to give you a solution, but I'm just letting you know what all skills are required. Okay. Then what else are required by a DevOps engineer? Again, this is a job by the company SAP, and they're hiring DevOps engineers, and these are the things that they expect. Again, they need Kubernetes, containers, Nagios. Nagios is basically a monitoring tool. They need cloud providers like knowledge of GCP, Azure. They also need to need Chef or Ansible. Okay, so these are some skills. Let's look at one more job profile. Let's talk about a company called Oracle. So they expect you to know cloud. You expect me to know CI/CD, Git, Docker or Kubernetes, Python, configuration management. So as you can see, most of them have the similar kind of skills which they are expecting in all the DevOps engineers job. Right? So let's list down what all are the skills expected. So you should know the configuration management automation tools that we have listed over here. Then you should know the CI/CD tools, basically the pipeline tools, Jenkins that we heard about. Then you should know testing tool. For this, the most prevalent framework which is used is Selenium. Then you should know cloud services like AWS, Azure, GCP, and then you should also know a programming language like Python. Okay, so these are the skills which are required by a DevOps engineer, and these, if you know, you're eligible to become a DevOps engineer. At the same time, you should also have strong Linux skills. Okay, that is also an expectation from a DevOps engineer. And if you have these skills, you can become a DevOps engineer. Now, the next question is how to get started. How do you get started when you probably know either half of it or 3/4 of it or 1/4 of it or 0 of it, and if you want to become this guy who's a DevOps engineer, how do you go ahead and become one? Okay, now there are two ways, guys. So either whatever skills I've told you, you can start off with these skills, right? So how do you start off? You start off by a programming language. Let's take the example of Python. You learn all the loops, you learn all the if statements. So this will hardly take around, if you have a non-programming background, it should take around 2 to 3 days to get a hang of how basically Python works with loops, if conditions, and some input output operations. If you get acquainted with this, I think you are good to go. So it'll take 2-3 days to get a hang of it, and then another week where you can practice some projects. You can go to websites like CodeMonk, you can go to websites like HackerEarth, where they have a lot of practice problems. You can go over there, try the beginner problems, and then I think that would be great enough. 10 days is good enough to invest on programming language. And that's how you get started, right? So once you are done with the programming language, the next skill that you would have to know is about cloud, right? So there are 3 cloud services which will mostly be asked from you. It'll be AWS, it'll be Azure, and it'll be GCP. Okay, so AWS is a cloud provider, which is the most popular cloud provider among all the companies that you'll be applying to. So it's a better choice to first learn AWS and then start off with Azure first and then GCP, because this is how the popularity goes. And when you start off with AWS, most of the concepts that you'll be learning in AWS will be the same with Azure and GCP, right? So when you start off with AWS, there are a lot of content online. You can go through a lot of documentation. You'd get the first thing that you'll have to do is you'll have to start by creating your account. You'll get a free tier for 1 year that you can practice on, right? So if you search on Google, if you research a bit, you'll get a lot of content that you'll have to go through. But yes, first you'll have to research a lot, and then you'll have to jot down in which sequence you would want to learn AWS. But if you try to research, there are websites that will basically tell you what to learn first and what not to. Okay, then you have to go ahead and learn about DevOps. Now, DevOps would include all these things: CI/CD, testing tools, automation tools, right? So in this, there are essentially, if we were to talk about the DevOps lifecycle, this is how the DevOps lifecycle looks like, right? So first you have create. So create basically means coding, right? So coding. So as a DevOps engineer, from the code perspective, you have to know how to do versioning in code. So you'll have to learn Git. You'll have to learn about how to verify it, which is basically testing. You'll have to learn about Selenium. Then how to package it, basically building the file. For that, you'll have to learn Maven. How to release it. For that, you'll have to know about Jenkins, because that integrates basically all the tools. And all the tools that I'm telling you guys, just write it down and you can search on Google. You'll get a lot of content on them. But yeah, you'll have to research and you have to study on your own once at least, and then try on and understand first the concepts, and then go ahead and then do the hands-on as well. Okay, then after release, you'll also have to learn some configuration management tools, which is basically Puppet, Chef, and Ansible, right? Because these are the most popular tools. Then for monitoring, you will have to learn Nagios, because that was one tool which is asked, and there are some other monitoring tools as well. But from my experience, what I've seen is Nagios is the most easy to learn tool, and you can start with that. And once you get a hang of all the concepts, you can actually go ahead and try on some other monitoring tools too, right? In this, we missed out on Docker, which is a very important tool, but Docker is something that you can actually touch in the end as well, because it's not related to all the tools that we just discussed, right? So learn about Docker, then start on with Kubernetes, which is basically a tool to manage Docker containers well, right? So if you go in this sequence, I think it would be a sweet ride for you. It'll take around 6 to 8 months with your hard work and your dedication towards learning those tools and following them. And if you follow it thoroughly, I think you would be equivalent to a 6 months experienced DevOps engineer. Okay, now once you're done with the tools, obviously you'll have to go ahead and learn a lot of best practices. So if you are not a developer and if you're not a system admin, you will have to learn how architectures are basically deployed on production systems, right? And for that, you'll have to go through a lot of white papers. So you can actually refer AWS white papers, you can refer Azure white papers, and if you go through them, you will understand how the architectures basically are in the production grade, and then you can start implementing the tools that you have learned on these production systems, right, with the help of those white papers.
Alright guys, so now that you know that you want to become a DevOps engineer, let me jot down the tools that you should know in order to become a DevOps engineer or a successful DevOps engineer in the industry. So let's get started.
Hey guys, welcome to this session by Intellipaat. DevOps is a set of principles which you can use to automate the complete development process in your company. And DevOps is so widely spread right now that a lot of organizations are trying to adopt DevOps because of its reliability. And in this session, we'll be learning the top 10 DevOps tools available in the market currently. So the first DevOps tool which you are going to look into is GitHub. GitHub is a software hosting or a version control tool which is currently a subsidiary of Microsoft. So Microsoft bought GitHub in the year 2018. So now let us see why exactly do we need GitHub. So developer makes a lot of changes locally to the source code, to the documentation, and also to the files available in the local environment. So to make those changes in the production server, the developer had to manually go over there and make these changes. But this process was time consuming. So to overcome this particular problem, developers came with an idea called GitHub. So what they did, they made some few commands and a particular background process. So whenever you make some changes in the local environment, you can track those changes and push those changes to the production server. So to do this, you just have to type a few commands in your local environment and that changes are made in the production server. So this was quick and also reduced time. So there are similar tools like GitHub. You can see like Bitbucket, Subversion, Mercurial, and also Azure Repos. So you can use all of these services to do the same commands and do the same operations GitHub provides you. So now let us see the next tool. The next DevOps tool which you're going to look into is Docker. So Docker is the containerization tool. What it exactly does is it creates different containers which isolates themselves from other containers and also the server so that it can have its own software, libraries and configuration. But why do we need it? Let me give you an example for that. If you're trying to launch 4 different Python applications which have 4 different versions, you cannot do that on the same server because Python does not allow you to have different versions of it in the same server. So what do? You use Docker. Docker creates you 4 different containers which can have 4 different softwares. That means you can install and launch 4 different versions of Python on the same server using Docker. And all of these Docker containers will be isolated from each other so that they cannot communicate within them. So now what you can do, you can easily launch 4 different Python applications on each of the Docker container. So this is why we exactly use Docker for. But what exactly Docker does is it does not virtualize the hardware components. Instead, it virtualizes the operating system. Sounds cool, right? Now let us see the next tool. The next tool which we are going to look into is Apache Maven. Apache Maven is a tool which you can use to automate builds, and it is mainly used on Java based code. It can also be used on other languages. Let me tell that later. First, let us see what exactly Maven concentrates on. So the first thing is it describes the way that software is built, and the second thing is it describes the dependencies that software requires. And how does it do that? It uses an XML file to do these things. So it describes the software, the dependencies and the configuration in a single XML file. So Maven can also be used on different languages like Ruby, C#, Scala and also a few more. But the coolest part about Maven is it uses a concept called Project Object Model or POM or POM. So POM is an XML file which describes the entire configuration of a project in a single file. So also there are similar tools like npm and msbuild which does the same operations like Maven, but npm does it with JavaScript and msbuild does it with .NET. So now let us see the next tool. The next tool which you are going to see is Jenkins. The sole purpose of Jenkins is to automate and integrate all the stages of a software lifecycle where we build and test the code. We can configure Jenkins as such. Whenever there is a change made in GitHub, the changes will be taken by Jenkins and the build and test process will be automatically started. So this reduces the human intervention and also anyone's dependency. As this process is instantaneous, the code will be tested and deployed simultaneously. So the star feature of Jenkins is continuous integration. So that is why it is extremely helpful. Now let us see the 2 reasons why Jenkins is widely used. The first reason is it is open source, and the second reason is it was created by a developer to help other developers in the development lifecycle. So now let us see similar tools to Jenkins. There are 2 different tools which is Bamboo and TeamCity, but both are not open source. So Bamboo comes with the Atlassian ecosystem. If you are using the Atlassian ecosystem, Bamboo would be easier to integrate. And then comes TeamCity. TeamCity comes integrated with a lot of DevOps tools like Maven, and both of these tools are not open source. You will have to pay for them so that also their support is better. And if you're doing an open source project, Jenkins is the best option because it's free and it has a lot of integrations with it. You can integrate Jenkins with cloud-based systems also. Now let us see the next tool. The next tool is Kubernetes. Kubernetes is a container orchestration tool. So why do we need it? It is used for continuous deployment of softwares which are already built. It is extremely useful for softwares which were built on microservices architecture. because it is done by orchestrating multiple containers. And also Kubernetes accepts Docker as a containerization platform. Kubernetes is an open source project which is basically built by Google developers, and it was donated to the CNCF, that is the Cloud Native Computing Foundation. Even now, Google, Red Hat and many organizations are active contributors for Kubernetes. The CEO of Hepsio, Joe Beda, has quoted that Kubernetes is an open source project which enables teams of any sizes, from a startup to a Fortune 500 company, to automate scaling, deploying and managing of applications on a group or cluster of server machines. Now let us see the next tool. The next tool is Artifactory. Artifactory is a JFrog product, and it is an artifact repository manager, or also called as binary repository manager. So what does it mean? So basically, when you store your code in GitHub and compile and run it, it will generate some binary files. You will store those binary files in Artifactory. Artifactory stores those binary files and also combines them with dependencies, which will give you a file which is called an artifact. And why it is called as a binary repository manager? As I already told you, when you compile Java, it will provide you jar or var files. So those files has to be stored somewhere, and Artifactory is the right place to store them so that you can push those files to a CI/CD tool. And also package managers like NPM, Maven and NuGet can be managed using Artifactory. And artifact repository managers are also considered as very useful tools currently, like the version control or CI/CD tools. Moving on. Now we are going to see two different configuration management tools. The first one is Puppet and the second one is Ansible. First, let us look into Puppet. To use Puppet, you will have to install the Puppet agent in all of the servers where you have to manage them. So after installing Puppet agent, those servers are called as nodes in regards with Puppet. There is this master server which has all the configuration files of all these nodes. So this master server checks for any changes in configuration files at regular intervals of time. And also all of these nodes check the master server for any change in their configuration files, and if they find any change, they pull those changes and apply it to the Puppet agent. And now let us see Ansible. So Ansible is very simple yet a powerful tool to manage multi-tiered applications also. But unlike Puppet, Ansible is very simple to set up because it does not need any agent or software to be installed on the servers, either in master or slave. The next tool is Nagios. Nagios is a monitoring tool, and it lets you monitor your servers, infrastructure and network. It is also said to be the best server monitoring tool in the market because of its flexibility, because it allows you to do both agentless and agent-based monitoring. It has a humongous 5,000 different add-ons which you can integrate and check metrics to get quality insights. And also the concept related with Nagios is continuous monitoring. So Nagios can be used to detect network issues and also overcome performance issues. Now let us see the next tool. The next tool is SonarQube, and it is a quality control tool. SonarQube quality checks your developer's code. What does it mean is, it checks for the readability, the bugs and the vulnerabilities in the code which got created, and also it is combined with the process called continuous inspection. So whenever there is a change in your code, SonarQube automatically executes to check the bugs inside your code. And also SonarQube can be implemented or integrated with already existing version control tools like GitHub, Subversion, Mercurial, Azure repos and many more. And also SonarQube can be used on many languages, currently 25 plus languages like Java, Go, TypeScript, Python and few more. And also SonarQube is widely used because of its easy integration with existing CI/CD tools and also other DevOps tools like Jenkins, Azure DevOps, GitHub and TeamCity. Okay guys, now let us look into the cloud tools for DevOps. So we know AWS and Azure are top cloud service providers, but do you know they also provide quality DevOps tools to create a development lifecycle? Now let us look into that. So first let us see what Azure provides us. Azure has a service called Azure DevOps, which provides us services like Azure repos, Azure boards, Azure pipelines, test plans, and also artifacts. So Azure repos is a version control tool, Azure pipelines is a CI/CD tool, Azure test plans is for testing, Azure artifact is an artifact repository manager, and finally Azure boards and dashboards can be used for monitoring. Now coming to AWS DevOps, it provides us 4 different tools, which is code commit, code deploy, code pipeline, and also code build. Code commit is again a version control tool, code build is for building, code deploying is for deploying like Kubernetes, and finally code pipeline is used to combine all these 3 services to create a development lifecycle. And here there is no monitoring tool, but you can use AWS CloudWatch for monitoring. So guys, we've seen all these tools, and AWS DevOps and Azure DevOps are also 2 different DevOps services which you can use to create a development lifecycle. So guys, we've learned what are the top 10 DevOps tools. We have chosen these tools because they are open source and also popular. There are still a lot of DevOps tools which are available for free. You can check them out.
Alright guys, I hope this video was useful to you, and if it was, please click on the like button and subscribe to our Intellipaat channel for any further updates. Also guys, if you have any questions with regards to this video, please comment it down in the comment section and we'll be happy to answer all your queries. Happy learning.